make all students aware about physics activities and some news and to guide them in their career. Okay, so outline of today's talk is first of all, I will tell why this topic that the physics of day-to-day life or physics of applications or gadgets. Then I will a little bit talk about importance of asking questions, and then actually we will see some gadgets, and then we will see what next. What next means what after this lecture and what afterwards. Okay, so in the introduction, we can see there are a lot of activities are happening around us, and we can see uh, there is some science or physics is involved in each of the activities or the applications we see or we use daily. So, in this today's talk or in this interaction, I would like to introduce some of the gadgets which you are very familiar with. And today's lecture is not to explain what physics is behind these gadgets, but I want you to know how to think while learning physics or any science. Because when you know how to learn, then you can learn by your own. So you don't need much support. So I'm here to interact with you. So I want you also to interact in between. So it need not to be only one-way traffic. You can also speak with me. Okay. So what is importance of asking questions? If any student is joined, they can try to answer this question. I mean, why it is important to ask questions, or any teacher also you can put their views.
For curiosity.
Sorry.
I'm saying that it is important to ask questions because of curiosity.
Okay. Okay. Any other to understand clearly? Okay. Very good. Okay. So there is okay. Both answers are correct. So to understand something, it is very important to ask questions, because if you can answer, then only you can clearly say that okay, I have understood this concept. I will give you two very famous examples for asking questions and which led to some discoveries. The first famous example is of Isaac Newton. He started to think why the fruit has fallen down and why it did not went up. So you all know he formulated then the theory of gravitation, and it has a tremendous success. So is it so that it only fell because Newton was sitting there? Some fruits were obviously falling before even the birth of Isaac Newton. So he started to ask questions, and not just he stopped to by asking questions, but also he tried to figure out. He tried to answer the question. He tried to find out the answers. Another famous example I would like to give you here is Albert Einstein. So before Einstein, also we used to have some clocks. We have some measuring devices for time, but we never thought to combine space and time. So he asked the fundamental question: what is time, and how it is related with the space? And therefore, you know, the famous theory of special theory of relativity and then general theory of relativity both were formulated with the question: what is time and what is space? So that's why uh, I'm encouraging all of you to ask questions and try to find out the answers. So today's talk is just a starting of how to look at something, uh, how to ask some questions, and what are the ways to find out the answers. So this is very common example which you see, whether it is ceiling fan or table fan. So, what physics principles can we learn from this application or appliance? Anyone can unmute and you can answer. Everyone
About
has.
angular momentum.
Yeah, please. Yeah, please, you can tell. Someone was saying the answer. Can you repeat?
Yes, I'm saying that we can understand the principle of angular momentum.
Angular momentum. Okay, nice. Can you elaborate?
Um, because the fan is rotating, we can think about a particle at the end, and from the center of the fan, the particle is rotating, and it has an angular moment.
Okay, okay. So that we can learn from fan. Very nice. Okay. Any other answers? What you can learn from fan? Can you ask this fan how it works, how it starts, how it start to rotate? Someone has mentioned in the chat application of motor. That's correct. So there is a motor here, which is behind the scene. We cannot see that directly, but there is a motor. Okay, so we can see the application of motor is there. So most of the time, why I'm choosing this topic today for this talk is while I was studying, some of my friends used to ask, "What is use of this? What is use of that?" Learning in the classroom. So we can see we have learned motor in our college days, or some of the students are learning that, but we have not applied. Okay, the motor is there inside the fan. So I will quickly draw a diagram here. Okay, so there is some magnet you can see. Okay, I will write here N, that is north, and here it is south. And there is a coil. I'm just showing you the only single rotation or a single turn. Okay. Now there is a okay. There are some sophisticated structures are there, but okay. What I'm showing you here is okay. The current is flowing through this, and what is the principle of motor? When the current flows through coil, it is in the presence of the magnetic field, and due to this two actions, there is a force acting on this coil or on this uh, what we can say turns. So it turns and it gives a mechanical motion. Similarly, we have the other way around, the generator. We can see it rotates, and then in the presence of magnetic field, it can produce the electricity. So what happens is we have supply here, and there are magnets inside the fan. Because of this AC current, this coil rotates, and now for the fan, it is not just single motor, it is connected with some other shaft. And to this shaft, the blades of the fan are connected. And when the current is passing, then this coil starts to rotate. And because of this coil starts to rotate, the blades of fan can rotate. And also you can see some aerodynamics is there. If you can see the shape of the blades, they are not plain. The blades are not plain. They are slightly curved. Like you can see the in the aeroplane, they also have slightly curved. They are also not straight. So some aerodynamics also you can see, because after all, what we need to get some cool air, or we get to circulate the air. So just motor is used to rotate this structure, these blades, but to get some air, we need some kind of particular shape for this fan. If that shape is not like that, then we will not get the air. We will not we will not able to circulate the air inside the room. So these three, you can see how many things we can see from this. So these are the applications. Some of the students used to open up the applications. So like TV remote or the toys they get when they are a child. So when you open up, then you can see the mechanism inside the system. If you open the speaker or the mic, you can see there are magnets inside. There are some coils inside. So what they are doing? So if you start to ask the questions to such instruments, and why these are like I said, why this shape? Okay. So when you start to ask the question and find out the question, you get more knowledge. You can also ask why only three blades. Okay, you can see the windmills also. They also have the same three blade structure, right? So why only three blades? Obviously, as I told, this I showed as a motor, right? So what happens here? Sorry, I will type. We saw this as a motor, right? But what if we can use it as a generator? The same structure we use in the windmill. So that is generator, right? So in the process or in this mechanism, the exact reverse process is happened. The rotation is used or is made with some mechanical energy, and because of that mechanical energy, in the presence of magnetic field, we get some kind of current or we get some voltage. We get generation out of wind energy, and therefore we can use it as a uh, energy, renewable energy source. So these things, uh, you can see they also have only three blades. I'm just showing like this. Okay. uh, I'm using the mouse, so please mind my diagram. But we can see the windmill like this, and most of us have seen them. So in that structure, what happens? This windmills are rotated, the blades are rotated, and inside that there are huge magnets and the coil. So the coil is rotated with the help of wind energy, and we can get the supply. So here also, how much should be the size of these blades? Why only three blades? Why not four blades? Okay, what will happen if there are four blades? We can discuss for a while on this topic. What will happen if we use four blades?
It will increase uh, in the amount of weight.
What will it increase?
The weight.
No, wind has to be increased.
I'm saying weight, mass will be increased.
Yes, mass will be increased. So how it will affect our windmill or our generator in this case? So you can see if mass is increased, inertia is increased. So you need higher wind energy to rotate these turbines, right? So if higher energy is wasted in rotating the turbine, then how much electrical energy you will get out of it? And therefore, three is okay. So you will say that okay, I will not increase the number of blades. Then why not two? If I reduce one blade, there will be only two blades, and mass is reduced, so it should produce the higher energy. But why not two? Can anyone answer? Or you can just start to think on this. I'm just extending the nature of fan. And I know you all have seen this. At least you have seen the fan. So what is happening in the windmill, I'm rotating now the fan, let's say with the wind energy or any mechanical energy, and I'm getting the electricity. So instead of 3 blades, if I use 2 blades, then what will happen? Yes, please. Sorry.
I think when we use two blade, if the speed is slow, then it will stop in between because there is a pi angle between the two blades. But if I use the three blades, then there is somehow it will rotate due to the inertia in the low speed too.
Okay. Any other answers?
Is it because of the net force?
Yeah, kind of. You're close to answer. Good. So what will happen if we have 2 blades? We may get some kind of rotation, but it is very poor. Okay, someone is raising hand. Interaction between surrounding wind and blades will reduce. Correct. That is also right. So if you see the theory of windmills or the structure of windmill, you will able to see that the area covered by this structure is also important, and the mass. So 3 is a number is in between very low and very high in case of energy generation and efficiency as well as cost effectiveness. So all the things are taken into consideration. Also, the three blood structure gives you more strength to the structure. So that are technical things. But if you start to ask the questions, then what you can get the answers. And what to get with the answers, I will explain it later. I will get okay. But I am sure that some of the things can be get cleared with the simple fact. If some of my teacher friends are also here, then they can show to the students, okay, that motor is used in the fan. You can also make student think, okay, the motor in fan and the motor which pumps the water are the same or different. Okay, so because we call motor in both cases, right? So I'm not answering these questions, but I'm started to make you think. I'm starting to make you think. Now these are gears. Okay, here I'm showing these are 2 gear train. It is called as gear train, and this is 3 gear train. But before telling anything, I want you to answer. Have you seen these gears anywhere? Where do we use them?
In car, in machine?
Which machine?
Machine like which is used to drive heavy masses.
Okay, okay.
In bicycles, motorcycles, and cars.
Correct. Good. In bicycles, in motorcycles, we use gears. In some heavy machineries, also you have seen this. So, what is use of these gears? And I will also tell you one other application which you might have seen. Oh, we don't know that we use gear in them. So that also I will tell you next. But we'll first finish about this. Why we need gears? So to know what is gear, it is just any circular ring or just like a wheel. It is a wheel, but it has some teeth, right? This is teeth. It's just like a wheel, but it has teeth, so that they can get in between these two. So if I rotate this one, or this is driver means this will rotate first, or we will supply the energy to this driver wheel, then what will happen? Because of this teeth like structure, it will I'm not sure what word to use, but it will make this wheel to rotate, right? And if you see any simulation, or here also you can see, if I rotate this driver wheel in this direction, okay, clockwise direction, then what will happen? this will start, sorry, this will start to rotate in the opposite, that is anti-clockwise direction. Okay, so can we say here that gears are used to change the direction of rotation, direction of rotation? If you say so, then I will show you another structure here, which is using three gears. This is a gear train of three gears. So this is driver gear here, and this is follower actually. And in between, we have another which is called as an idler gear. Okay. So in this case, the driver gear and driven gear or follower gear has the same direction. Then why we need to use the gears is the question. Okay, we have seen some gears, but why we need to use gears? You can answer now.
I think to reduce spending of energy, to reduce power.
To reduce power, but we need to use some energy to rotate one wheel, right? So now we have two wheels, so we might need double energy or extra energy. How it will reduce the energy? Yes, physics tutorial has raised hands. Please unmute and tell.
Yeah, here this is Girish. Am I audible?
Yeah, please.
Yeah, I think this is to increase the mechanical advantage.
I'm not sure how it will increase the advantage. What kind
A
of
number of gears if attached. So gears are the pulleys if they are attached. So certainly they increase, they reduces the effort and increases the value of load.
Okay. So instead of this two or three gear structure, should I increase number of gears? Will it be helpful? And another question in this is it necessary to have the size of these two gears is same or it can be different? Which one should be smaller? Which one should be bigger? Can be there some criteria, or does it depend on the application?
I think gear is used to change control the speed or change the direction of the follower using the driver. Just like in the cars, we use the reverse gear or the forward gear in number of times, which will increase the velocity of a car, or we can change the direction by reverse gear.
Right. Good. So the gears are used to either change the direction as we seen here in the first picture, or you can see here the first wheel is a bigger and second wheel is a smaller. You might not able to see exact circle, but the case is okay. This is bigger and this is smaller. So, or it can also be the reverse case. The first one can be smaller and the next one can be the bigger one. So they are used to change the speed, right? So if you use bike or the bicycle with gear, if you change the gear, you can see some gear you will feel okay. It is easy to rotate the pedal. At some stages, you will feel on some gears, you will feel that okay, it is harder to push the pedal. Have you observed this? Because on the bike it is difficult to feel because it is depend only on speed, but for a bicycle it is directly connected to your muscle energy, so you will immediately feel that okay, if I change the gear, the energy I'm putting on the pedal has to be changed, right? So it depends on obviously the application. So we have multiple gears in the single bike or bicycle. This is to when we need a speed, we use different gear. When we don't need speed, but we need steadiness or we have a rough surface, then we use another kind of gear. And so this is the thing. So we can alter the speed in the bikes we don't need to change the direction, but in cars we can change the direction because we have reverse gear as well as forward gears. So in that we may use this kind of thing to change the direction. But here we can change the speed depending on the uh, teeth of driver and follower. Because you can see, it would be better if I show you the animation. Uh, Let me check quickly if I can show. Yeah. Yes, you can see. I hope you can able to see. Now, first wheel is rotating, okay, in anti-clockwise direction, and you can see the second wheel is rotating in clockwise direction. If you look at this teeth, sorry, if you look at the teeth, you may get confused. But if you see at the center, the direction of this rotation, okay. So if this is rotating like this, other one is rotating in the opposite direction, right? So this is just animation. Actually, there are some other animations also where you can see one. Uh, okay, anyway. So what I wanted to say, suppose one gear is rotating. This gear is rotating 2 times, then this gear rotates 4 times because this is smaller. One gear completes one rotation. In between this smaller gear can complete 2 rotations, or it can have 1.5 rotations, depending on the number of teeth. That is called as gear ratio. So it depends on the gear ratio. So if you change the number of teeth or the size of the wheel, we can see, or size of gear, we can see that okay, the speed can be increased or decreased. If you have any questions, you can ask in between also. So, okay, you told me the examples of gear, that is bicycle as well as the bike. But I'll show you next application. In that we use gears, but you have not seen that. Okay, and that application is clock or watch, wristwatch you use. Behind the scene you might have seen the suppose someone is repairing the watch, you might have seen them. Okay, there are some gears inside the system, and how they rotate, each what we can say, it's like it's connected to different gear. So therefore they have different speed of rotation. Okay, all are connected to some kind of gears, and all are running with the motor, just like our fan. There is a motor. Similarly, here also some kind of motor. Some of you have seen, okay, this kind of uh, wristwatch or this kind of clock use some cell, battery cell. Okay, so okay, before I tell you, you can answer me, or you can tell me what else we can learn from this. Apart from gear, have you used some kind of watches which does not use battery or cell?
No.
Okay,
Yeah,
if you,
there are the watches.
yeah,
There are the watches which they do not carry sails. They
uh,
use the spring system, and the elastic potential energy of the spring that is converted into the rest of the mechanical energy, the part of the
correct,
mechanical
correct,
energy.
right, right.
And
So
I think, sir, one more thing,
yeah.
increasing or selecting the gear ratio or the number of teeth of the each gears, does
Mhm.
it has any effect on the torque also?
On
Torque,
car, yes, yes.
torque.
torque.
Yeah.
Yeah. Yes, sure. That's why we can see the shift in speed.
Yeah. Okay.
Yeah. Okay, so he has answered one, or he has given one example of some toys. Also, you might have seen. We have to give some key. We have to rotate that, and then they will play. They will move forward, or like some clocks. They run for some time, and then again we have to turn the key. So these are some kind of watches, but some watches, they might have, you might have seen the quads on the watches. Okay. Okay. There again. Okay. Anyway, so what they use quartz crystal inside them, and they have a very interesting property which is called as a piezoelectricity. Sorry. Does anyone know about piezoelectricity? Yes.
Yes, sir. The electrical energy or the potential difference that is developed because of the pressure, or I should say pressure difference. That's the
Right.
piezoelectricity.
Right. So, in most of the sensors for sound, we use this kind of piezo sensors. What they do, when there's a pressure applied on the diaphragm, they vibrate, and because of the vibration, we can get electrical signals. Or if we get electric signals, then they vibrate. So this both way, just like I told about fan and windmill, or motor and generator, they can act in a opposite way. Similarly, the quartz crystal are inside them, and whenever we get a small pressure on that, and such watches run on the pressure of your hand. So you just have to wear the watch, and it will run forever. So I don't know why such watches are not in market today. But I have used such watch. It was given by my uncle. So he used the watch where we never used a cell inside or battery or a key. Okay, it will run automatically whenever you are whenever you are wearing that. So with the pressure of your hand, it will automatically run. So you start thinking that, okay, is it possible with such a small voltage? Because you can see, to rotate the this uh, I don't know what it is called in English. Uh, all three arms of the minute hand, second hand, and hour hand, we can rotate it with very small power. So it is sufficient with the piezoelectricity. Okay, and therefore such watches can exist. So you might search if we can get such kind of watches still. Okay, but here with the watches, we can see that, okay, we can have some piezo material. So piezo related to the pressure. So if we apply the pressure, it will produce the electricity, and that electricity will run the clock or wristwatch. So that things we can learn from this clock. Also, there are some other pendulum-like structures. You might have seen such big watches, sorry, big clocks on the wall. Uh, so you might have seen such kind of clocks. They have used pendulums. So this pendulum is used for the keeping time, because if you know, uh, T for a pendulum is equal to 2 pi into under root of L by G. So G will never change for a particular place. And if I keep the L, that is the length of pendulum constant, it will also not change. And therefore, in this such kind of clocks, they use pendulum here. And this pendulum was driven with some kind of electricity, or here some quartz crystals for piezoelectricity, and or some cells, and that is connected to one of the either hour hand or minute hand or second hand, and then using gears we have connected it to other two hands so that we can control their speeds. So you can see a lot of physics is involved in such a very simple structure or simple instrument we use, but we never think about this, right? So whenever you will start to think about this, you will get to know more and more. And why I'm telling this? Okay, we will finish this and then we will discuss. So electric bulbs. So I have shown these two different kinds of bulb. This one is, can anyone tell what are the differences or what it is called?
The one is filament bulb, and
Yes,
another is the LED.
correct. So what are the differences?
Filament bulb converts the electrical energy into heat and light, and here in the LED that works in the emission spectra, that the on the principles of the semiconductor.
Okay, okay. So here, depending on what is standard of students we are teaching to, we can tell what, or we can teach what to learn from such instruments. But you can see this filament is made of tungsten, and whenever you switch on, this changes the color if you watch it closely, because it gets heats up and it turns reddish, and after heating then it start to emit the light, and this is because of heating it emits the light. So this is called as black body radiation. So you might teach that. And here in the LED it is just electronic transition, and therefore, because we need not to waste energy in the heating, LED bulbs are more efficient, and therefore people are telling you to use LEDs because they are energy efficient. So you can save the energy with the same wattage. What is watt? Watt is the power used to glow this bulb. So even if you use higher wattage filament bulb, we can get more light energy with the help of lower power LED bulb. This is because we need not to waste the energy in heating of the filament. Okay. So you can also discuss what is black body radiation in this kind of bulb, simple bulb. And you can also discuss electronic transition using the LED bulb. We can also have a other small instruments or any appliances you use daily. I'm listed here. Yes, you can see. These are also some of the examples we can see. We discussed bicycle a little bit. Then the refrigerator, how it works, how it is different from AC or cooler. What are the differences? What is electric oven? Electric iron, we iron to close. Then what is pressure cooker? How it works? How it is related to PV is equal to nRT, the ideal gas equation. So these small things we can show them. Okay, this is working, and here it is a physics. Uh, Means there are a lot of things. What we can learn means how it works. From how it works, we can see where we have seen such kind of effect or such kind of motion. All the things we can learn from all these things: television or radio, mobile, anything you see, you can start to think about that, and you will get some kind of phenomena, science in it. Okay, what are the applications of this? So what next? Suppose I am asking questions and I'm starting to answer and or finding answers. What next? What is use of all the things? So what do you think? What is use of asking the questions? One thing we answered initially, that to get something more, to get knowledge. But is there any other application of asking questions? What do you think? How can we use this asking question? Yes. Yes, someone was answering.
To make our life better.
Okay. Okay. In one way, it is correct because if you know how it works, it will be easier to take care of that instrument or of that particular applicants or a gadget you use. Yes, that's correct. Okay.
Physics and technology go hand in hand. If we know the physics, then it is easier to develop the technologies. In sometime technology lets the physics, or sometime the physics lets the technology to develop.
Correct. There are some okay. Questions help to improve existing things. Humans are curious, correct? Very good. So we can improve few things, or we can bridge between few things. Like I will tell you. So you might have heard about the lotus. If you see their leaves, the water cannot stay there, or the water falls down. If you so it does not wet in proper language. So it depends on the surface tension, all things. But humans started saying how it is happening, why it is happening. Can we mimic the structure? And then now with the using nanotechnology, we are able to make some clothes or some paints which are waterproof, or we can it is called as hydrophobic nature. So hydrophobic means they are water repelling. So even if there is a dust, if you pour water on it, it will automatically clean because nothing will uh, adsorb on the surface, it will remove because of the hydrophobic nature. So what we can do, we can start mimicking the things. Like you might have heard autobiography of Dr. Kalam, Wings of Fire. He started to think how birds fly, or even before in the history, people started to think, okay, if bird can fly, human also can fly, and therefore we can see the technology is evolved and we can build aeroplanes. So the asking questions does not only answers question and gives us knowledge, but they also lead some kind of innovation. Also, I had told the examples of Isaac Newton and Albert Einstein. So they started to find, and we know how grand success they got with their theories. So this is the effect. So what kind of questions we can ask? We can actually ask anything, but these are some major WH questions we can ask: what, how, why, when, where, and etc. What is this like? What can be done next? How this is working? How to use it? Or why this gear is used here? Just like I mentioned earlier, or why quartz is used here, all the things. When to use which gear, okay, where to use which. So that we can start to ask about any application or any gadget you are using. But this is not just enough, but we have some more questions: what not, how not, why not, when not, and where not. So these first kind of questions seems to be positive, but they only provide us the knowledge. But these questions, they may provide you some inventions, because just I told how the bird fly. Someone is asking how the bird will fly, they will get knowledge. Okay, how they do this. Why not we fly? So this question is applied, and then aeroplanes are invented. So all the students and my teacher friends, I would recommend you to ask questions and try to find out the answers. This may lead to some innovation in future. So thank you for listening patiently. If you have any questions, you can ask.
I have a question.
Yes, please ask.
Is asking questions is the first step in doing science, or is there any other alternative way?
Yeah, most of the time, asking question is important. Uh, Sometimes we may not need to ask. Sometimes we need to believe in some things. Like suppose before Einstein also, we used watches. Just as I said, we used to believe, okay, this is 1 second. So we may not ask, okay, why is it only 1 second? Or some facts we cannot question much. Like why only one satellite we have, natural satellite, that is moon. So we have to believe. So we cannot ask such questions, but we can ask, okay, how far it is, what is effect of that. So some questions we can ask, but for some trivial we say we cannot ask questions. But whatever we knowledge have, we should ask questions to that knowledge. Then only you will create a new knowledge, or like I said, invention. Suppose we are using piezoelectricity. So in India there are some state where if the vehicle goes from the speed breaker, they produce some electricity. So India has built such kind of roads. So why is it possible? Because we know, okay, this is piezoelectricity, but we will ask, can we use it? So that is the application. So I insist you to ask questions. Okay, there is one question in the chat box. Sir will force on the object. Okay, sir is there is a comma. Will force on the object reduce when split into sine and cos component when given with some angle? Will there be no splitting of components when the force given perpendicular? Okay. So here I will answer this with the drawing. Suppose there is a box, and this is a surface, some kind of surface, and you want to pull this to uh, this side, okay, towards the right. Suppose you apply force in this direction. Will it help? Obviously, no. You have to apply force in this direction. Suppose if you apply force in this direction, now you can see there are components to the original force, one of which is in this direction. Therefore, you can see some kind of motion in this direction. Now you can see this motion is not necessary, but it is there, or the force is there. So the question is the component splitting of forces. Splitting of forces means single vector, this vector. If you are applying this force in this direction, or if you apply the same force in some other direction, suppose in this direction, the magnitude of force will not change, but the effect may change. Effect on the object may change. I hope that answers. Yeah, also, yes, also the component may also change, but the magnitude is not changing. Okay, so suppose if I do this here, so now I'm using different angle. Now the components along x-axis and y-axis are different. Okay, but the magnitude of vector is same. Components might change. It depends. All right, that is right. Yes, any other questions?
Sir, is the interest in physics is only the key ingredient to pursue physics, or the person may have a potential to tackle the problem or deeply inside of the physics?
Okay, obviously interest is one of the thing, because if you are not interested in the thing, after some time you will get irritated or frustrated. But obviously, if you start to learn something, obviously I'm telling you this is very interesting. Not because I'm learning it, but because if you start learning, it will give some interest, because it will give you some insight. Okay, because of this thing, this is happening like this. Particularly in physics, we have two different aspects, I can say. First one is mathematics. So most of the theories need rigorous mathematics, like modern quantum mechanics or general theory of relativity. We need strong mathematical background. Even if ISRO launches the rocket, we need a strong mathematical calculations of orbits, in which orbit it should be there, after which time, how much fuel is needed. So all calculations are needed. So mathematics is one of the part of physics. The other one part is we can call as a logic. So if we have a logic, logical thinking or analytical thinking, we say, and if you are good at math, then physics is easier subject, I would say. But if you understand few things, then it will become interesting. By the way, it was a nice question. Thank you. Also, you can okay, still I'm sharing this again. Okay, I will show you. So YouTube is the best platform to learn many things. So you can search anything you want. Like, yes, I searched what is gear before this preparation of lecture. So I have seen this video. Many videos you can see. You can see the animations. You can see the simulations. Okay. I will share one website which is called as PhET simulation. So if you type this PhET simulation, PHET simulation, you will get this website, and this is free website, free to use. Student or teacher, they can use it freely. Simulations. I will focus on now physics only, but they also have some other subject areas. But we mostly focus on physics. So it is physics learning through interactive simulations. So you can see there are lots of simulations are there. So simulations just like a game, right? So you change the parameter and you see what is changed in the result. And through this changing parameters, you learn few things. So that is also important. Just don't do conventional only book reading or any paper reading. Do such innovative things. You can use simulations. There are some very good YouTube videos also. They show you simulations. Okay, so that way, why simulations? Because it is easier to understand when you are learning a theory, as well as you are looking at the effect or the result, right? So I would recommend you to watch the lectures by Sir Walter Levin. Many of you might know. So he has lectures, but I would recommend, yes, this 801 and 802 is also there. So 801 is related to classical mechanics, and 802 you can also search here also. Yes, 801 or 8.01 and 8.02. You can search here and you will get full playlist. Okay. So why I'm telling you to watch such kind of videos, because he's telling us what is happening, and then he's telling what is math behind it. So what happens is, just I told, maths and logic both are hand in hand. In our old, we can say, education system, what we do, we learn theory in some class and we do practical after some time. So there's some gap in between, and in between we forget things, and that is obvious. But if you see both simultaneously, it is less chance that you will forget. Okay, this is 801 as well as 802, both you can see. Okay, so we should test. Okay. So this is one of my favorite lectures of his, and you might also seen his lecture of the last lecture. So I'm just showing you titles. So yes, it is for 1 hour. So you can watch it, and he has mentioned several effects in a single lecture because it was his last lecture, a public lecture. So that is, so you should see such kind of things. You can see the videos by Fermi Lab. They also use some kind of uh, yes, this one. So they can also show you some videos with imagination, you can see, or animation you can see. So such videos will help to create interest as well as to gain knowledge. So I would recommend such videos. Uh, yeah, that's all. Any other question?
Sir,
Yes.
so it's a general question.
Hmm.
So is there any group uh, like in the world? There are many physics students, and is there any common platform where all the people come and discuss physics? Is there any some kind of workspace?
Yeah. So currently we are doing this activity with the help of AIP, that is Association of Indian Physicists. This is also one platform. If you are a teacher, then there is Indian Association of Physics Teachers, IAPT. Um, there is also one. Okay, I will show you this. In this only. Yeah, International Association of Physics Students. This is for only for student, and this is an international group. So we can become member only if you are a student. For teachers also, you have some groups. If you are using LinkedIn, then there also you can form a community of your whatever you like. I mean, uh, your subject area expert you can talk with. So LinkedIn is also best platform to get in touch with such people which you have common interest or common subject area or common specialization. On Facebook also, if you are using, then you can get some groups. So I have worked in this while I was in MSc. We had NC India, there is a National Committee for India. But I'm not sure whether it is working now or not in India. But internationally, mostly in Europe, it is working. Uh, yeah, but now we are using platform of AIP. So I will also discuss about AIP. Is Sanjay sir joined? Because it is better if he explains this. Or Captain Sir. Okay. So we have formulated this AIP, that is Association of Physics Indian Physicists. I guess we have also website. Deepak sir, do you have the website? Can you share in the link chat box?
Please pardon.
Can you share our website link in the chat box?
I will try my best.
Uh, okay, let me search also. Okay, this is American Institute.
I will share later on. Now, as I'm joining from the phone, I have little bit difficulties
Yeah,
in doing so.
I found it. No issue. I will share this in the chat box. Okay. So this is a solution which is working under JS Foundation. It is loading. I will close live board. Wait. And this is you must use. You must check all the things here. Okay, some issue is there. Okay, but you can go on and check. This is basically a platform. We can discuss many physics things. We can discuss careers, and you can also find us on YouTube. So previous lectures also you can see. Because you are already joined in the group of talk. You can also get the video link of this video later, and then you can see other videos also. Maybe somehow this is not working. Yes, you can see here is this. On this, you can see discussions and lectures already done. So if you are having interest in particular kind of, you can see here career guidance and all things. You can check on this. I myself have my own YouTube channel. So if you want, I will share here. First of curiosity. So here also I have shared some kind of we have playlist. So you can see some guest lectures are there, and what next? Yeah, webinar. Here also you can see we had guest lecture with career opportunities in science. So yeah, we have a lot of groups, but you need to search on. You are already in one of the group here. Still, this is loading. Okay. So I would suggest we can get connected with this group as well as some. I'll stop presenting. So you have a lot of platform. You have LinkedIn, you have Facebook, this some website you can search. We can also have Vidyan Bharati. You might have heard about, uh, or Vibha it is called as.
Okay, sir, I'll see later.
Yeah, yeah, yeah. Any other questions?
Sir, I have only the last question.
Yeah.
Sir, will gap year affect my physics career in future?
What?
Will gap year affect my career in physics in future?
Get
Gap year.
gap year? No, not much. Because I also had one gap. Uh, but okay, that's fine. When do you have gap? I mean, after MSc.
Uh, Actually, I am a 2022 pass out MSc student,
Okay.
and I'm preparing for a CSN net exam.
Yeah. Yeah.
So that's why it's been already 1 year. So I'm little bit of anxious. That
Okay.
really affect my career in physics.
Okay. So
You
I'm
you
also.
you need not to worry about your gap year. Okay, it's far better you focus on your net CSIR net. Once you clear it, you can go for your PhD in the better places. So please focus on your study. So there is no issue about it.
Yeah.
Okay, sir. Thank you.
My
Thank
answer
you, sir.
also is the same because I'm personally I have taken one gap after my MSc for CSR net, and after qualifying, I'm doing the job. But if you have cleared your basics, your fundamentals, then you need not to worry about your gap, because if you can show the result, then no one will show you no one will ask you why you have taken the gap. But you have to prepare in that gap. You have to become better.
Yes, sir. I'm preparing from the standard textbooks, actually clearing my basics.
Okay. Yeah. Someone was speaking. Madhavi. Okay, I guess there are no more questions. Um, Okay, then. Thank you everyone for joining this lecture, and keep asking questions. And we are community for discussion of this physics uh, knowledge and careers also. And thank you for joining again. With this, we will meet the next lecture. Thank you. I guess you can stop recording. I don't know who is operating now.